Welcome to another tutorial of PowerFactory. Today we are going to see how to implement a power rectifier using PowerFactory. This is often the case that in industrial network, the existence of power rectifiers is very common. One such simplified example is shown in the schematic here. On top you see the grid Q, then transformer and a rectifier, and finally the system is connected to a load of 500 kilowatts. Now this is a quite simplified model, but as in the coming tutorials we will see the importance of analyzing the simple circuits and then going to the complex ones. So on top we have a grid 20 kilovolt and having a short circuit power of 20 MVA. Now for the transformer, it's a 22.4 kilovolt transformer, whose power is then 20 MVA. The short circuit power is 4% with a vector group of DYN1. The rectifier we are considering today to be an uncontrolled diode bridge rectifier with a power capability of 1 megawatts. Let's now turn to the PowerFactory software and implement the circuit. For that, I will open a new project. Let's name it Rectifier. Okay. And the grid is 50 Hertz. Let's leave the settings to be the default ones. Close. So for the circuit implementation, we have three bus bars, 2 AC and 1 DC. We have one transformer and the rectifier itself, and of course a load. For that, let's take one bus bar here. I want to implement from left to right, so let's take, or maybe from top to bottom as shown in the schematic. Let's call this one grid bus bar. We need another. Let's take a copy of it and paste it here somewhere. And to name it a terminal 0.4 kilovolt, and I need to change the voltage level as well. Yes, for this it is 20 kilovolts. Let's take another bus bar here for the DC one. And this one should be terminal DC. And the system type, since we will connect the output of the rectifier, we should change the type of the system to DC. And OK. So let's take a grid and connect it to the grid bus bar. Take it on the top of the bus bar so that we have a better visual. Then we take a 2-winding transformer and connect it to this bus bar and to the lower one. Let's do it again. So the transformer is then connected. So if we look into the component list, we see we will have the rectifier with 2 DC connections and the rectifier or inverter with 1 DC connection. I will take this one with 1 DC connection. Click on this window here and see it's telling us to connect the AC side first. Let's do it. The AC side is then connected to the 400 volt bus bar And now it's prompting us to enter the DC side, which we will do here. And we need to connect a load to the DC bus bar. Let's choose a general load type, connect it here. Let's rename it to the DC load and also select the type of it. It's a DC load flow, and the active power of the load is 0.5 megawatts. Load flow 0.5 megawatts. All right, let's enter the parameters of the grid and transformer as well. I'll call it a slack bar to take it as a reference. And here we had 25 MVA. I also enter the same for the minimum values. And R by X ratio is 0.1. Let's close it. For the transformer, let's call this transformer to be TR, and it's a 20 by 0.4 kilovolt transformer. Let's select the type, new one. The transformer has a power capability of 20 MVA. High voltage side is connected to 20 kilovolt side and 400 volt on the secondary side. Short circuit impedance is given to be 4%. The vector group is delta YN1. That's all for the transformer information. Yes. Let's click on OK. And let's now enter the value for the rectifier. Now, since this is an uncontrolled rectifier, you see we can decide here what type of converter it should be. I is for the inverter and R is for rectifier. Let's call it just a rectifier, uncontrolled. We need to select a new project type for that. And the rated AC voltage for this rectifier is 400 volts. And we can choose what type of the semiconductor is inbuilt in the rectifier. For our case, it's a diode rectifier. And for built-in transformer, I will leave the default values and click on OK. For the load flow, here we can select the nominal value of the power set point, which is 1 megawatts. Click OK. For the load, we already defined the parameters. So if everything is fine here, if we just run a simple load flow analysis here, it should run without any problems. If we see the message, too many information, let's clear them. Rerun the load flow. Okay, so we see we have a warning here. Nominal voltage differs by 30.45% from bus voltage. Is where the rectifier is then connected. It's 4 kilovolts. Yes, this is also important. If this rectifier is connected between a 400 volt AC bus bar and a DC bus bar whose voltage level we defined to 0.4, which is not correct. If we rectify 400 volts, on the DC side, the voltage should be 1.35 times 400 volts for uncontrolled rectifier. which in this case is 0.54 kilovolts. If we now enter the correct values and rerun the load flow, before that I will clear the output window and run the load flow again. Let's check. So we do not have any warning and the load flow calculation is then successful. So there is no error in the model anymore. Now if we see quickly, well, it's 0.6. Can we rearrange it even better? Okay, a couple of things I would like to do here as well. I want to plot the AC side voltages, DC side current and voltages, so that we can clearly see their instantaneous waveforms and verify the results ourselves as well. For that, let's select this bus bar and define the RMS or EMT simulation, and from where we can select what variable we want to plot. Let's select EMT simulation, and bus name we select everything with the star. We want to show the three-phase voltages of that bus. And for that we need to go to the line-to-line voltages, which is U1 is a kilovolt line-to-line voltage. For phase B and C as well, click on OK. I will take another EMT simulation here and define the variables for that. But for the DC bus bar, I think for the DC voltage and current, I need to define it on the load. Let's go to right click on the DC load, then define RMS and EMT simulations. DC load, double click here. And here we need to select the EMT simulations. And see, for this bus bar, we can select what we want to see. So we need the bus current phasor magnitude is okay. Power, I will deselect them. And we also need the voltage in kilovolt. Where is the voltage? V1 was kilovolt line to ground. The other one was in per unit, and I will remove it from the list. These two are what we need. So the definitions are okay. Let's insert a new graphic. Select the visual or virtual instrument panel. I would like to call it the plots. Now in the blank window, you can go to the append new VI section, click once. Since I need 3 windows for that, it's already selected here, subplot of 3, click OK. On the first window, I want to see the AC side voltages of the rectifier. So I come here, result file, double click, select all calculations. From the element, double click. It's 400 volt bus bar, T 400 volt. And then from the variables, we should see then the defined 3 phase voltages or line-to-line voltages. Done. For the second one, we need to plot here the, let's call it the DC load voltage. So I select all calculations again. For the element, it should be DC. No, it is the DC load. I apologize. DC load. And from here, we need to select what it should be. Let's call it the line to ground voltage. That is the DC bus voltage. And similarly for the currents on the third window. Current. Now to run EMT and RMS simulations, we need to select this option, RMS EMT simulation, this tool, and then this will be activated. So we need to calculate the initial conditions, and in order to see the instantaneous curves, it's important to select this option as well, electromagnetic transients. Execute. This will run the initial conditions, and then to run the simulations again. If I click there, it asks me for what time the simulation should be run. Let's call it 0.1 seconds and execute. So the simulation is run, and we need to rescale the axis, which we can do by clicking here, scale x-axis automatically, and this one, scale y-axis automatically. So now we see the curves of the simulation. By the way, you see the PowerFactory software for this specific version starts the simulation time from -0.1 seconds. If this is not what you want, you can change it by going to this toolbar here, where you calculate the initial conditions. Go to step sizes, this window, and then you see the start time is specified to be -0.1 seconds. If you just tip here 0 seconds, then it should start from 0. Let's rerun the simulation to see the effect. Now you see the simulation starts from 0 seconds. So we need to rescale the axis again, and we have it from 0. So if we quickly check the values, you see the effect of commutation is also noticeable on the line-to-line voltages on the AC side. This is the DC voltage, which I'm expecting to be around 0.54, but it's a little more than 0.54 as I can see. But we will find out how to correct it, or where the explanation for that is lying. And the current is at around 0.83 kiloamperes. These we should be able to see if we run a simple load flow analysis here. You see we have a bus voltage here and the DC bus by 0.6, which is a little higher than the expected value of 0.54 kilovolt. And we should see a current flow here. Let's zoom it a little bit here. So here to the load, you see we have the current value is 0.88 kiloamperes, which we also see here on the plots. But the voltage, you see, it should match exactly 0.54 if we have an AC voltage of 400 volts. So let's check now here and into the settings of the rectifier. If we select it here, and for the inbuilt transformer is that minimum turns ratio can vary ±10% of the per unit value. That means if we want to have exactly the theoretical calculated values on the output side, we need to put 1 here. If we do it and recalculate the results, let's check. Or maybe even for a load analysis first. So here you see for this, it's 0.5. We don't see the second one. So for that, we need to check how we can show until the second decimal point. Edit format for note. And then decimal places. You can select the value. I should get 2. And also for the EU is the same too. So now you clearly see we have 400 volt on the AC bus bar, which is here. And 1.35, then 400 volt is 0.54 kiloamps. That's what we're exactly calculating, we're getting it. And for the load current, it's now 0.9 kiloamperes, which we should be able to see from the graphs as well. So since we ran the simulation again with the updated values, you see the current is going up now. So we need to rescale again to see the values. See, now is the current is average values around 0.93 kiloamperes. And the average value of the DC voltage is 0.54 kilovolts. So once we understand this basic implementation of the rectifier circuits in PowerFactory, we will see later that in very complex industrial grid, we have inverters, we have rectifiers, and other type of loads and converters as well, since they're part of the modern industrial network. This is extremely important to understand the functionality of the components present in the network, which we'll do in coming videos as well. I thank you for your attention, and you can let me know if you have questions from the tutorials. Thank you.